Hi everyone, it's me, Franklin. Welcome back to Comp 2160. It's Friday, happy Friday, and what I want to do now is just like last week, I'd like to take a look at the high-level learning outcomes that we covered this week, talk briefly about them, and tell you maybe a little bit about how you might be assessed on those learning outcomes in the course. So let's take a look. Here's the course schedule. This is the ROAS. This is on the course webpage, the syllabus. And this week has been kind of a bunch of different things that we've done. So the very first learning outcome that we have here is write code that takes advantage of its environment through simple command line options to define runtime behavior. We didn't do that part. That part we're going to come to a little bit later in the course. And the other part of this was the redirecting of standard input and output for file I/O. So this is very much using that greater than and less than sign to redirect either files to be the input of a program, redirecting to a file to be the output of a program, or sending data between programs using that pipe character like this. You're going to be assessed on this in the assignment, in assignment 1. And the way that you're being assessed on this in assignment 1 is that we are expecting you to use fgetS to read a file from standard input. And the way that we're doing that is just using that redirection operator to send the file to be the standard input for that. The other way that you might expect to be assessed on this is in something like a term test in a written question, where I would ask you to demonstrate either being able to make choices about which of those 3 symbols that you would use, or by writing a complete command on the command line that would show, this is a program that produces output. I want to put it in a file, so I'm going to use the greater than symbol to make sure that that output goes to a file. The next learning outcome that we've got here is describe concepts of in-application memory management, such as first bit allocation, the runtime stack and heap, and garbage collection. For this week, we're really specifically focusing on this, the runtime stack and the heap. In class, what we did was we spent time visualizing these 2 different parts. So we took a look at that really big overall, this is what memory looks like. And we talked then a little bit about where in this virtual address space for a process does the stack and the heap go. So this is from the operating system's perspective. And then we spent a little bit of time visualizing what the stack looks like as a function is called in a program, and how addresses are passed around between parts of the stack. We were thinking about this in the context of the next learning outcome, recognize potentially risky programming techniques and how they differ in different high-level programming languages. So very specifically, this was about things like, if we're using a function like scanf, how does using scanf potentially affect things like the runtime stack? So if we have a stack allocated array, if we use a function like scanf for input, or if we do something wrong in terms of what we're writing with code and just go past the end of the array, we could potentially corrupt the stack that we've got or make changes to variables that are not what we're expecting them to do. You're going to be assessed on these 2 learning outcomes together, kind of implicitly in the form of you have to write code for the assignments. In this assignment, the way that you're being assessed on this is that right now you are working with strings, and you are working with a recursive implementation of an algorithm, and you kind of need to make sure that you can keep things in order so that you are not overwriting other parts of the stack when you're making copies of strings or when you're passing the strings to functions. As we go forward in the course, you're going to continue to be assessed on this in assignments, where instead of just trying to keep your string in order, we're also going to start to make sure that we're writing code defensively. In the last class, so yesterday, lecture 8, we started to use structures. One of the things that we started to do there in terms of coding defensively was to make sure that we are checking the values that are passed to us to make sure that they're within the bounds of an array that we've allocated. In terms of the way that you're being assessed on this in the assignment that you're working on right now, and again, also going forward, this is also related to making sure that you're passing sizes of arrays to functions in C. We don't have that array index out of bounds exception, so we have to make sure that it's our responsibility to make sure that we're not causing exceptional behavior to happen as opposed to letting the language do that for us. You might be assessed on this in the form of questions on a term test or a final exam, either by here's some code, what's wrong with this code, please fix it. I might ask you questions that are related to visualizing how the stack is changing as we're running code. So here's a brief snippet of code, show me how the stack looks either at the end or how it changes as each line of code executes. We're not thinking about the heap yet. We're not really at the heap, and I'm not really too concerned about that, but it's something that we will look at going forward. Yeah, and I think I said that it might be something like I show you code, but if I ask you to do coding on a test, I'm going to expect that you're doing things like passing sizes of arrays to functions and using preprocessor directives to declare the size of an array in the place where you're declaring that stack allocated array. The last two learning outcomes here, I added these kind of after the fact because like I said in class, I'm starting to think about assignment 2 and I want to make sure that you can get started on assignment 2 when it's published next week. And so define the interface to an abstract data type and define the implementation of an ADT with a private data structure. We started working on this in the form of using structures in C, struct, and we started doing this in terms of writing functions to work with the structure that we're defining. The very first thing that we're going to be doing next week is to start using an interface to take that implementation out of our main function and put it into its own module. So separating that implementation out and then beginning to hide information about the way that it's implemented, with the end goal being I want to be able to have a string that uses an array to begin with and then change the way that it's implemented later. I want to switch to using a linked list later, but I don't want to change the code that uses my library. I just want to change the implementation of my library. And so we're going to talk a lot about the mechanical use of interfaces. This is next week, but for this week, what we've got is using a structure. So declaring a structure, declaring a new type, declaring instances of that structure, and working with a structure using that dot notation to access properties within it. You might be assessed on this. You will definitely be assessed on this in the form of an assignment. Assignment 2 will expect you to do this. You may be expected to use structures in code that you're writing on an assignment. That's the learning outcomes from this week. The one thing that I do want to point out just on the course webpage is that I posted a little discussion point here. So if you're kind of following along with what we've been doing in class, take a look at this. And if you can answer this question, send me an email. If you can answer this question, send me an email, and I'll give you a badge on UMLearn for that. But I will eventually talk about this in class, but yeah, I think it's a little bit of fun. So I hope that you have a great long weekend, everyone, and I will see you all on Tuesday. Bye.